This video clip, we're going to work through the solutions to the first progress check that we've done this year. The grade boundaries that we're going to use are the same boundaries that we'll try to apply all the time, which are the ones that were matching the GCSE numeracy papers from the summer of 2018. So you're looking mentally to be pushing for half marks, 40 out of 80, in order to be getting those level 2 qualifications of a grade C or a grade B. So roughly, with a running total of these questions, you're looking to be, if you score full marks in the first 7 questions, then you are pushing that level 2 grade C or beyond grade. So just something for you to be mentally checking as you're working through the questions. Question 1. The following is a list of ingredients to make 24 scones. So 480 grams of flour, 150 grams of milk, and so on. Calculate how much salt, flour, and milk would be needed to make 36 scones. So I have to scale up this recipe in order to have enough of each quantity in the right proportion to make 36. Now, there's lots of different ways of thinking this through. The mathematical thing to do would be to see what the scale is between 36 and 24. How many times bigger is that? So in order to do that, you would do 36 divided by 24. And you'll see there that it's 1.5 times. So you would need to increase every one of those quantities 1.5 times, so multiply each of them by 1.5. You could do it, and lots of people are very comfortable with this, by recognizing that that's, well, it's not double it, but we need another 12 scones, which is half that quantity again. So rather than by multiplying by 1.5, you could say, well, if I half those quantities and add them on, it'll give you the same thing. It doesn't matter. Both methods work. So salt, for us, is 2 times 1.5, which is 3 pinches. Flour, 480 times 1.5. 720 grams of flour. And milk is 150 milliliters, and you multiply that by 1.5 as well. 225 milliliters of milk. Question 2, similar question. Here is a recipe for spaghetti with a tomato and basil sauce to serve 4 people. Complete a version to serve 10 people. So you could do it by saying, well, I need to double it to make 8. I then need another 2. So I need half the quantities again. So you'd be doubling those quantities and then adding on half of those quantities. Or you would do 10 divided by 4 to work out what the scaling is. So 10 divided by 4 is 2.5. So we have to multiply each of these by 2.5. So we'll be doing 400 times 2.5, 1000, 14 times 2.5, 35, 4 times 2.5, and over here 4 times 2.5 again, 2 times 2.5, 800 times 2.5, 28 times 2.5, and finally 20 times 2.5. So that's the important thing, is to work out what the scaling is, whether you're doing it by doubling and halving, or you're just doing one straightforward line of maths. Use the information given in the recipe to complete this statement. 100 grams is blank ounces. So you're looking for one of the equivalents which links grams and ounces. So we could either use that one or that one. So if we went with that one, if 100 grams is 14 ounces, by dividing that by 4, it would give me 100. If I divide that by 4, I also have to divide that by 4. So 14 divided by 4, it's about 3.5 ounces. Question 3. The formula for converting centigrade to Fahrenheit is given below. So F equals 9C plus 160 all divided by 5. Use this formula to calculate the temperature in Fahrenheit when it is 25 degrees C. So when you are replacing a letter by a value into a formula, if you imagine that what you're doing is smashing into that letter, into that variable, to make a hole to replace it with the value. And when you make that hole, the hole looks like a pair of brackets. So when C is 25, F will be 9. There's a hole there which I'm going to replace with 25 plus 160 all over 5. So where there's a variable, it becomes a hole, which is represented by the brackets. Now on our Casio calculators, we can type that in exactly as we see it. Where we see a fraction in the formula, we can create the fraction. On the top of it, typed it in exactly as I see it, move to the bottom, 5. So I've written it and calculated it in exactly the same way, and I get 77 degrees Fahrenheit out of it. You won't get any marks for the units because it doesn't ask you for them, but I'll put them in anyway. So this one, C is 0, F will be 9, create the hole to put the 0 in, again, looks identical to what I've written, 32 degrees Fahrenheit. And then the last one, same again, except now we've got -8. And what's important to remember with this is when you're putting in a negative value onto your calculator, it's a different button from subtract. That's your take away subtract button. That's your negative value button. So it's that one that we're going to put in there, the -8 plus 160 divided by 5. So 17.6 degrees Fahrenheit. Question 4, conversion graph. In a hospital clinic, the following information is used to convert between kilograms and pounds. Use the information below to draw a conversion graph. Now, so far, or initially, there's no values on the axis, so we need to put those on. And the kilograms, we're going to go from 0 to 68. So can I fit 10, 20, 30, 40, 50, 60, 70? Yes. So that one's going to go up in tens. And then my pounds axis, the vertical one, needs to go up as far as 150. So can I go up in tens? 10, 20, 30, 40, 50, 60, 70? No. Can I go up in 20s? 20, 40, 60, 80, 100, 120, 140, 160, yes. Because what you want to do is to choose a scale that's going to use as much of your graph as you can. There's no point in going up in, say, 100, 100, 200, because everything will be in this small area. Now, conversion graphs are almost certainly straight lines. So to draw a straight line, I need to find 2 points. Now with pounds and kilograms, 0 is the same in both. So I know that I'm going to have my graph going through that point. I've then been told that it's 39.86. So 39 is there. It's going up in 2's here. So 80, 82, 84, 86. Those are my 2 points. Gives me all I need to draw my conversion graph. Use your graph to find an estimate for 50 kilograms in pounds. So 50 kilograms is there. So I'm going to go up to 50. I'm going to mark it on the graph to show my examiner that I know what I'm doing, in case I misread it. So that's, this one's going up in 2's, remember, so it's 100, 102, 104, 106, 108. Pounds. LBS. Find an estimate for 200 pounds in kilograms. So this is quite a common question where they give you a conversion graph but then ask you to find a value that doesn't fit on the graph. So 200 pounds is off the scale. So what you have to do is find a value that's on the scale and then multiply it up in order to turn it into 200. So if I read off 100, I can then double that to make 200. So from the graph, 100 going this way, reads off as 45. So 100 pounds is 45 kilograms. So 200 pounds is twice that, 90 kilograms. So when you're using a, or presented with a conversion graph where you're asked to find something that's off the chart, that's what you do. Another way you could have worked that out, you could have read off, say, 140 and 60 and added them together. So that's another type of way you could go about solving that question. Okay, so this is an OCW question where you get marks for organisation and communication. How you lay out your workings, how you convey what you're doing to the person that's reading the work. So Cup of Joe smooth roast coffee is sold in a variety of sizes: 200 grams, 100 grams, 400 grams. Decide which size of Cup of Joe is the best buy and why. You must show the calculations to support your decision. So with any best value question, what you need to do is to get the same quantities of each product that you're comparing, and then once the quantities are the same and you've calculated the equivalent costs, you can make that direct comparison. In this case, there's lots of different ways you could do it. You could make them all 400 by multiplying that one by 4 and that one by 2. or you could make those two 200 by multiplying that one by 2 and halving that one. But generally what we usually push towards with questions like this is to be working with hundreds. So the cost per 100 grams. So for 200 gram jar, the cost per 100 grams will be, halving that means I got to half that. So half of £5.60 £2.80. So the 100 gram jar I don't have to do. So 100 gram jar is £3 per 100 grams. And then for the 400 gram jar, cost per 100 grams, I've got to divide that by 4 to get 100 grams, so I have to divide that by 4. So £11.80 divided by 4, £2.95. So to work out the best, which one is the best value for money, would be the one that costs the least per 100 grams. So the one that costs the least per 100 grams is the 200 gram jar. It only costs £2.80. So to conclude, the 200 gram jar of coffee is the best value because it has the lowest cost per 100 grams. So of the 6 marks, 4 of them are for the arithmetic, for bringing these down to a comparable value, and then the 2 of them, one of them is for explaining what each line of maths is doing. So there I'm working with the cost per 100 grams, there I'm working out the cost, there I'm working out the cost, and then I'm drawing a conclusion from the maths that I've done. The second organisation, communication and writing mark is usually for consistent units. So the fact that that's money and I've got pounds, that's weight, mass, grams. So I've got all my units where I need them. That's how you pick up those 2 marks. Question 6. The supermarket sells 500 grams pots of natural yogurt for £1.50 each. During the first week of April, the supermarket has a special offer. Buy 1 pot and get the second pot half price. 2 weeks later, the price of the same 500 gram pot of yogurt is still the same, but the supermarket changes the offer to buy 2 pots and get a third free. Keenan always buys 6 500 gram pots. Which would have been the better offer? Well, let's work with offer 1 first of all. Buy 1 pot and get the second half price. So 1 pot is £1.50 and the second one will be half that price, which is 75 pence. So if I'm in pounds, that will give me £1.50 plus 75 pence is £2.25 for 2 pots. So he wants to buy 6 pots, so he needs 3 lots of that. So £6.75 for 6 pots. So offer 1, where the first one is at full price and the second one is at half price, means you're paying £2.25 for 2 pots. You want 6, so you need 3 lots of that bargain, £6.75. With offer 2, buy 2 pots, so £1.50 each, and get a third pot for free. So that comes to £3 for 3 pots. Now if it's £3 for 3, he needs 6, so I need to double that then. So that's going to be £6 for 6 pots. So which is the better offer? The second offer. Because it works out 75 pence cheaper for him. Question 7. So this is another OCW question. A band was hired to play at a local hall. The hall was hired for a cost of £20 per hour. The band cost £150 to hire. Tickets for the event cost £5 each, and 128 tickets were sold. Calculate how much money was spent and how much money was collected, and the profit or loss made on the event. So when you're working with profit or loss, it helps if you separate incoming and outgoing. Work with those, and then the difference between the two is whether it's made a profit or a loss. So the outgoings for this (4 hours of the hall at £20 per hour). So hall hire will be 4 hours times 20 is £80. Okay, so I've used that piece of information. The band cost £150 to hire. And then we're talking about incoming here. So those are the outgoings. So the total outgoings will be 80 plus 150, which is £230. So it's costing the organisers £230. Income are £5 tickets selling 128. £640. Use that piece of information. So they make 640, they spend 230, so they're making money. There's a profit, not a loss, and the amount of profit is the difference between the income and the outgoing, £410. OCW, I'm explaining what I'm doing. It's easy to see the stages I'm making, and I'm being consistent in the units that I'm using. Question 8, similar question. Eleanor plans to sell cups of juice at a disco. She buys 8 bottles of juice. Each bottle holds 3 litres and costs £3.65 per bottle. The total cost of the plastic cups she uses is £2.50. Each plastic cup is filled with 250 millilitres of juice and is sold for 75 pence. She sells all the juice that she's bought. How much profit did she make? So again, we work with outgoings. So she buys 8 bottles of juice and they cost her £3.65 per bottle. So we've got 8 lots of £3.65. So she spends £29.20 on the juice. And she also buys plastic cups, £2.50. So that is all the information on what she spends. So total outgoings will be £29.20 plus £2.50, £31.70. That's how much she spends. So cups. So each plastic cup is filled with 250 millilitres of juice and is sold for 75 pence. She sells all the juice. So what we need to work out here is how many cups she sold. Three litres is the quantity of juice that she's putting into 250 ml cups. So you need to know, in order to work the next bit out, that 1 litre is equivalent to 1000 millilitres. So 3 litres is 3000 millilitres. So she's got 3000 millilitres of juice that she's going to pour into 250 millilitre cups. So the number of cups sold will be how many 250s fit into 3000 ml, which is 3000 millilitres divided by 250. 12 cups. And she sells those cups for 75 pence each. And I'm working in pounds, so I write that as 0.75, so 12 lots of 0.75, £9. So how much profit does she make? She doesn't make any profit. Makes a loss of £31.70 less £9, which is £22.70 loss. So there you go. Question 9. Income tax. Loretta is paid in euros. She's checking her tax bill for last year. The tax rates last year are as follows. No tax on the first 3,500 euros of earnings. Earnings between 3,500 and 10,500 taxed at a rate of 25%, and earnings above 10,500 taxed at a rate of 35%. Last year, Loretta's total earnings before tax were 34,500 euros. So up to 3,500, zero tax. Because she's paid 34,500, that means that what she's being paid above 10,500 is at 35%. So the difference between what she's earning in that tax band, she charged tax at 35%. So let's work out what that is. You can put it in the calculator exactly as we see it. 34,500 less 10,500, close the bracket, times 35%, 8,400 euros. Then what she's earning in this category, in this band, which is the gap between the 10,500 and the 3,500, she's charged at 25%. Which is 1,750. And then the rest of it, the 3,500 to zero, has got zero tax, so that's €0. So her total tax is 8,400 plus 1,750, which is 3,500. No, it's not. 8,400 plus 1,750 is 10,150 euros. So you're breaking the total earnings into the three different tax bands. The first 3,500 is at zero. Anything within the next band is at 25%, and she's earning above that band, so she gets all of that at 25%, and then the difference between her earnings and the top band, work out the remaining part. Question 10. So we got Mr. Williams with 10 tomato plants. Numbers that grew on each are given below, and we need to calculate the mean. So to find the mean, it's the total divided by the count. So the total we get by adding them up. 42 plus 37, 48, 34, 44, 41, 39, 42, 38, 45, 410. The count, how many are there? 10. So the mean is the total divided by the count, which is 41 plants. 41 tomatoes. For the median, we're looking for the middle value, but we have to put them in order first. So the smallest one there is 34. So what I do when I'm rewriting the list, to put a little dot under so I know I've already included that one. Then I've got a 37, 38, a 39, 41, 42, another 42, a 44, a 45, and a 48. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because there are 10, that means we have two middle values, not those two though, idiot. Those two, so I got 1, 2, 3, 4 that side, 1, 2, 3, 4 that side. So I'm looking for the halfway between the two that have been chosen, which is going to be 41.5. And the mode is the one that occurs the most, and there are two 42s, so that's 42. Next summer, Mr. Williams plans to buy more tomato plants like the one above. He says, on average, I should get about 41 tomatoes from each plant. Give a reason why his data shows he's correct. Well, he's correct because out of the averages, the mean is 41. The median is 41.5, the mode is 42, so they're all around about 41. So, but you can just focus on one of them and say he's correct because the mean tomatoes is 41. So you want to make sure that in your sentence you are using the word mean and 41 or the median or the mode, but you need to be relating back to those measures. Children in a primary school class were asked how many pets they each owned. The information was displayed on a vertical line diagram as shown below. Complete the frequency table below and calculate the mean number of pets per child. So 0 pets, 9 children. 1 pet, 6. 2 pets, 10. And 3 pets, 3. To work out the mean, you want the total and the count. The total, well, those 9 kids had no pets, so that's 0 in total. 6 had 1, so that's 6 pets in total from that group. 10 had 2 pets, that's 20 in total, and 9 in total there. So the total of all the pets is going to be the sum of those. So 20, 29, 35. The count is how many children. Now it's not telling you in this question how many children there are, so we need to add those up. We've got 10, 13, 19, 28. So the mean is the total divided by the count, which is 1.25. So 1.25 is the average number of pets. Now we all know we can't have 0.25 of a animal, but nevertheless, because it's a mean, we would still give that as a decimal value. Question 12. A more complicated set of data here. So the context, a group of pupils was timed in completing a maths test. The results are shown in the group frequency table below. So let's just check we understand what's going on here. If I pick this row, it's telling me there were 17 pupils who finished between 5 and 10 minutes. Draw a grouped frequency diagram to illustrate these results. So with a grouped frequency diagram, the bars are connected. So between 0 and 5, we have 19. Now this is going up in jumps of 4, so halfway would be 18, and halfway again would be 19. So that's 2.5 squares down. So that's 19 between 0 and 5. Between 5 and 10, 17, which would be 2.5 squares up from 16. Between 10 and 15 is 10, which is going to be halfway. 1, 2, 3, 4, 5. Halfway between 8 and 12, that is. 15 and 20 is 5, which will be 2.5 squares up from 4. And finally, between 20 and 25, it's 2. 1, 2, 3, 4, 5. Make sure in an exam paper you use a pencil. I'm using a pen so it stands out on the camera, but you would be wanting to rub that out if you realised you made a mistake. Calculate an estimate of the mean time. So I know there are 19 pupils who finished in those 5 minutes, but I've got no idea exactly what those times are. So this is where we work with a mid value. So halfway between 0 and 5 is 2.5, and we're saying our estimate is that all of those 19 calls within there would average out around about the midpoint, which is 2.5. These 17 would be halfway between 5 and 10. These would be halfway between 10 and 15, 15 and 20, and 20 and 25. So we now need to work out what the total calls are, finishing times for each of those categories. And even though they've given you the working out down there, most people find it easier just to annotate the table that you're given. So we would work out what each of those are. So 19 times 2.5, 47.5, 127.5, 125, 87.5, and 45. So to work out the mean, I need the total divided by the count. So the total is the sum of all of those. So 47.5. I'm going to write that down as well, so that if I make a mistake, I can still get a mark for showing that I'm doing the right thing. So that comes to 432.5. Count is the number of pupils completing the test. Now it's not telling us how many there are in the question, so I need to add up the number of pupils as well. So 19 plus 17 plus 10 plus 5 plus 2. 53. So the mean is 432.5 divided by 53, which comes to 8.16 minutes. Now look at the context of the data. Most of the data is between 0 and 10, so you would expect it to be around about 8 minutes. So I'm quite confident that I've got that one right. Right on the modal group. Modal, most frequent. What one occurs the most? 19 pupils is the most, which is between 0 and 5. Median, I got 53, so I'm looking for half of 53. So I'm looking for around about the 26th. So running total, the first 19 are there. That's going to take me to 46. I'm looking for the 26th, so the 26th is going to be in that group. Question 13. 5 single-digit numbers need to be written on the cards above. The median, mode, mean and range of all the numbers must be 5. Right, a possible set of single-digit numbers on the cards in ascending order. So they're going to be ordered. The median must be 5, so that means I know that that one is 5. The mode must be 5, so there must be at least 2 5s. But what we don't know is whether it's going to be a lower 5 to have 2 numbers bigger than 5, or a bigger 5 to have 2 numbers smaller than 5. The range must be 5, and for the mean to be 5, so mean of 5 numbers equals 5. So this is the reverse averages bit. This means that the total of the numbers must be 5 times 5 is 25. So they have to add up to 25. So now I can make a choice. Let me think. If that one was 8, then for the range to be 5, that one would have to be 3. So I've got 8 and 3, difference is 5, so that satisfies the range. I've got the median is 5, and I know that one of my others must be 5 as well. So if I add those up, I get 8, 11, and that is 5, which is 16, and another 5 is 27, and I need to make them add up to 25. So it can't be 8 and 3, that won't work. So if I was to take that as 6 and that as 1, then that would be 5, and then I'd have 10, 16, 17, which would make 17 adding up to 25 would be another 8, so that wouldn't work. So let's try 7. If that is 7, that is 2. So that gives me the range. These now add up to 10, 17, 18, 19. So to make the 26, that would then give me another 6. So that would then become this. So let's see if this works. So I've got a total of 7, 13, 23, 25. They add up to 25. The range is 7 take away 2, which is 5. The mode is 5. And I know the mean is 5 because they add up to 25. So 2, 5, 5, 6 and 7 will satisfy all three. And then the final question is another reverse mean question. 25 students in the class, 10 girls and 15 boys. On one particular night, the mean time spent on homework by the boys was 1.6 hours, and the mean time spent on homework by the girls was 2.1 hours. Work out the mean time spent on homework by all the students in the class. So in order to do that, first of all, I need to know the total time spent by boys. So the reverse average, I know the number, I know the count, I know the mean, so the total is going to be 15 times 1.6, which is 24 hours. Then the total time spent by the 10 girls will be 10 lots of 2.1, which is 21 hours. So now I know, or now I can find the total time by all the children in the class. Mean time of the 25 pupils will be 24 and 21, which is 45, divided by the count, which is 25, which is 1.8 hours. So there you go, that was Progress Check 1.